So in this video we're going to be doing functions. Okay, so firstly this over here is a function and this over here is a log function. Now when doing it, let's see. So firstly, state the domain of G. So when any time you want the domain of any function, you look at the x values where there's a restriction. You know for a fact that a square root of a negative is a non-real number and you can't do that. So this, basically any number in the square root has to be greater than and equal to 0. So all you do is say the number in the square root sign must be greater than or equal to 0. Then solve for x. So 3x is greater than minus 1. And then x is greater than and equal to minus 1 over 3. So x must be greater than minus 1 over 3. That's the final answer. But your domain, remember, we're just solving the equation here. So to rewrite the domain, which is going to actually be the final answer. So it's going to be including 1 over third to positive infinity. Because think about it, right? And you do not include, because infinity you don't include. So obviously anything less than 1 over 3 will make it negative, so that will be non-real. So obviously it's 1 over third and everything on the right, so it's positive infinity. Okay, so now the range of h. Now always look at the mark scheme. It's one mark, so it's something simple. So y is equal to log 10 to 10x. So now you might think, how you do this? How do you do this? Anytime you get it, just sketch the graph, right? That's basically all you do. Now, okay, so I'll show you a basis. I know for a fact this function will look like this. And by just drawing the function, I know my range, right? It's simple. But how do you know to draw this? Now, if you have, let's say, log. Now the important number to take off over here is this number over here, not this number. So if it's a number between 1 and infinity, so like greater than 1, greater than or equal to 1, it'll always look like this, the graph, always, no matter what, like this. If it's like, let's say in between, this value is in between 0 and 1, so like I'm talking about half, a quarter, 1 over 8, so if it's half, this can be any number. The graph will basically look like this. Look at that. So that's how I know to draw like this shape. And it doesn't matter what it touches here, because at this point you're just looking for the range, right? The range is all the y values. And if you look at it, what are all the y values? All y values are everything over here and over here, right? Now, if you look at it, it's all values, because this continues. It goes down, 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 and this carries on going like that. There's no restriction, right? So, your answer will be y is an element of real. So, y is an element of all numbers. So, negative infinity to infinity, right? That's how we do it. Evaluate it. Okay, so this is what we call a composite function. So whatever graph is like after the circle, it basically means put this graph in that graph. So if you look at it, we basically need to put this in H. Okay, so first what you want to do is, okay, let's do it one time. So h g of x. So what will this equal to? It will equal to this, so log 10 times, because now you're putting that in, the x, so we're putting the x as 1 over root 3x plus 1. So 1 over root 3x plus 1. We can simplify this to log 10 and brackets 10 over root 3x plus 1. So that will be your final answer. It's 1 mark, so it makes sense. Okay, so now you have to do this. So basically they're saying, okay, we made this h and g, right? I mean, we made this a composite function. But now we want you to put 3 in x. So what does this mean? So basically what it means is this. Wherever you see an x, put 3. Okay, so over here, the x is over here. So if I'm going to do it, let's see. So, if you do 3, so now I'm just thinking, let's see how it's going to work, right? 10 over, so the root of, now let's simplify this completely. 3 times x, which we made now, is 3. So 3 3 times 3 is 9 plus 1, that's 10. So now I'm looking, 10, 10, something's going to happen here. Now, be clever here, right? How can you rewrite this whole fraction? So, if you look how you can rewrite this whole fraction, right? I'm thinking, let me make the square root of 10 equal to 10 to the power of 1 over 2. There's an invisible 1 over here, and there's an invisible 2. So, that's a rule, right? You can say that 10, 1 over 2 can be rewritten as this. So, if I rewritten that as 10 and 10, 1 over 2, what's the rule I can use here? Exponential laws, right? So that will be, I can say this exponent minus this exponent, so 1 minus half. And 1 minus half is 10 to the power of half, which is also the square root of 10. But we don't need to know that now. Oh, we need to do this now. This is what I'm thinking ahead. So if I put 10 to the power of a half, right? Because this whole thing simplifies to 10 to the power of half. Log laws. I need to get rid of this half. Because if log 10, 10, I know that's 1. Log 10, 10 is 1. So exponential law says that I can put the exponent in front over here. So it's half times log 10, 10. And guess what? Log 10, 10, this whole thing is equals to 1. So it's a half times a 1, which is equals to, I'm sorry, not minus, well, it's positive. So half times 1 is 1. So, wait, half times, half times 1. Okay. Half times 1. It's half, right? Because any number times 1 is by itself. So the answer will be half. And that is my final answer.